This video describes how to conduct environmental water sampling for Legionella. We'll discuss the supplies you will need and demonstrate how to sample a shower head. Then we'll briefly discuss what happens when the samples arrive at the lab. Before you begin, ensure that you have the resources that you will need in terms of personnel, subject matter expertise, and supplies for the field team and the lab. You'll also want to gather as much information as possible about case exposures to guide your sampling plan. It is very important to take a team approach when sampling for Legionella. Your field team should consist of at least one epidemiologist and one environmental health specialist. Make a rough sampling plan before arriving on site to estimate the number of people you'll need on the field team and the amount of supplies you'll need to bring with you. It is helpful if you have already completed an environmental assessment. If this has not been done, plan to do this before you begin sampling. Meet with the building owner or management as well as a building engineer and maintenance technician when you arrive on site. It is important to consult with those who understand the water systems in and around the building when you are making your final sampling plan. We'll start with a description of the supplies you'll need. Before you go into the field, assemble a sampling kit. The kit shown here may be assembled before it is needed and stored at ambient temperature for up to 1 year. We recommend using an insulated cooler with wheels as a container for your supplies. This will protect your samples from temperature extremes and be easily portable. It should have the lab's address and a receiving point of contact clearly printed on the lid in case it needs to be shipped separately. There are 10 items essential to your sampling kit. They include sterile bottles for taking bulk water samples. We recommend taking at least 1 liter of water when sampling. A solution of 1 normal sodium thiosulfate to neutralize residual chlorine in water. A means of dispensing 0.5 milliliters of the sodium thiosulfate into the bulk water bottles. One way to do this is using a disposable 1 milliliter pipette and a pipette bulb. You'll also need Dacron-Tipped Swabs with wooden handles for sampling biofilm. Do not use cotton-tipped swabs. Pack screw top tubes and a rack to hold swabbed biofilm samples. The 15 milliliter polypropylene centrifuge tubes shown here are a good size to contain most swabs and are readily available from a variety of suppliers. You'll need a way to measure the pH of the water, such as this pH tape. You'll also need a way to measure residual chlorine used as a disinfectant. One option is the Hawk Colorimetric Test Kit. Pack a digital thermometer to measure water temperature. Digital gauges for pH and chlorine are also available, but remember to store the batteries separately from the units to prevent corrosion of the contact electrodes. You will also need labels for your sample bottles and tubes and a means to document your findings and take notes. You may keep notes on a laptop or other portable electronic medium, but we have found that it's more convenient and less potentially damaging to the laptop to take notes by hand on site and then transcribe them to an electronic format later. Some additional supplies that we strongly recommend include an extra bottle for collecting water to measure temperature, chlorine, and pH. This eliminates cross-contamination of samples. Alcohol pads for disinfecting surfaces. Extra writing utensils and packing tape to secure the cooler for transport. If you are flying, remember not to apply the tape until after you have cleared security. Pre-printed mailing labels that include the lab address and account number are convenient for quickly shipping samples back to the lab. You may also wish to include some optional items suggested by experienced field teams. These include a plumber's wrench or other general-purpose tool. But remember that due to liability, it's best to let an on-site maintenance technician remove and reassemble fixtures for you. You may also need scissors and extra labels as well as extra plastic bags to protect notes from any leaking samples during transport. The screw top closures to sample bottles and tubes are usually secure enough for transport by road or air without leakage. However, you may decide to also seal screw tops with parafilm if you anticipate long or arduous travel routes. Gloves are nice to have in order to protect yourself from grossly contaminated samples, such as those from hair traps and cooling towers. If you decide to stock gloves, remember that it's best to avoid latex due to the prevalence of allergies. It's a good idea to bring your own biohazard disposal bags, so you can avoid putting items such as used gloves and pipettes into the regular trash. Finally, it's always a good idea to have a packing list. A cooler like this one will hold enough supplies for 25 bulk water and 25 biofilm swab samples. For large buildings, you may need a second cooler that just contains bottle swabs and tubes. You are now ready to go into the field and begin sampling. Now we'll demonstrate how to sample a shower head and a faucet for Legionella. If your sampling plan calls for sampling a shower, ask a building maintenance technician to first remove the shower head. You should collect one bulk water sample and one biofilm swab sample for each shower in your sampling plan. First, label a 1-liter bottle with an ID number. Record the ID number, date collected, sample type, and the sample description in the log. In this case, sample type is bulk, and sample description is shower, room 413. Use the bottle to collect a bulk water sample from the hot water tap in the shower. Add 0.5 milliliters of 1 normal sodium thiosulfate solution per liter of water to deactivate the chlorine. Replace the cap and store in the cooler for transport. Then, let the hot water run until it is at its maximum temperature. In order to determine whether the water is suitable for the growth of Legionella, use the extra plastic bottle to collect a small amount for measuring the temperature, chlorine, and pH. Rinse the bottle thoroughly first if there is excessive sediment or discoloration in the bottle from a previous sample. The ideal temperature range for amplification of Legionella is between 77 and 108 degrees Fahrenheit. The temperature of the potable hot water at the tap should be well above this range. Chlorine can be measured using a Hawk test kit. The colorimetric method is shown here, or it can also be measured digitally with any pool test kit as long as the kit is sensitive enough to detect the lower amounts of chlorine present in potable water, usually between 0.2 and 1 parts per million. Absence of chlorine at the tap may indicate a problem. Be sure to measure total chlorine if the public utility uses monochloramine for disinfection, or if the method of disinfection is unknown. For systems that use chlorine, either total chlorine or free chlorine may be measured. pH can be measured using test strips as shown here, or it can be measured digitally or with any pool test kit. The pH should be neutral between 7.2 and 7.8. Discard the water used to test for temperature, chlorine, and pH. The same bottle can be reused for the next sample. To collect your biofilm swab, label a plastic tube with an ID number. Record the ID number, date collected, sample type, and sample description in the log. In this case, sample type is swab, and sample description is shower, room 413. Add 5 milliliters of water from the shower so the swab doesn't dry out in transit. Then, take a biofilm sample by firmly and deeply swabbing the inside of the pipe. Dacron swabs without transport media are preferred. Do not use cotton swabs. The biofilm may be black, yellow, green, or clear. Place the swab in the plastic tube, break off the end so it fits inside, and tighten the cap. The procedure for sampling a faucet is the same as that for sampling a shower. Ask a maintenance tech to remove the aerator and proceed with collecting a bulk water and biofilm swab sample, as well as recording the water's temperature, chlorine, and pH. Now let's see what happens with all those water samples when you get them back to the lab. Water samples should be processed within 24 hours of their arrival. If this is not feasible, they may be stored at 4 degrees Celsius for up to 48 additional hours. The minimum reagents needed to process a potable water sample are shown here. These include a filter unit to concentrate the sample, a tube with 5 milliliters of sterile water in which to deposit and vortex the filter, and buffered charcoal use media of increasing selectivity. Each biofilm swab requires 1 milliliter of acid for treatment and media of increasing selectivity for processing. The media, equipment, and reagents shown here are enough to process 25 bulk water and 25 biofilm swab samples. We would consider this a small sampling operation. Most outbreak investigations involve 2 to 4 times this number of samples in order to do a full survey of suspect sources. So it is extremely important to make sure you have adequate lab capacity before you begin taking samples. Further information on expanding your lab's capabilities or finding suitable external laboratory partners can be found in the reference section at the end of this presentation. This concludes our water sampling demonstration. Keep in mind that your sampling plan may include additional potable water sources, as well as other water sources like whirlpool spas, hot water heaters, and cooling towers. For additional information, please visit our Legionellosis resources site and the Elite Program website. Thank you.